Section 10.3 is solving quadratic equations by completing the square. So far we've learned a couple of ways to solve a quadratic equation. So the first thing we did was we factored to solve a quadratic equation. So we've used factoring. And the second thing we did was to graph. So now we're going to use a new method called completing the square. Okay, so first of all, we're going to go over what it means to use a square root to solve an equation. So if you have an equation like x squared equals 9, if we take the square root of both sides, the square root of x squared is x, and the square root of 9 is plus or minus 3. In other words, if I plug positive 3, I will get 9, or if I plug negative 3, I will get 9. So this symbol, plus or minus, means that either sign, the positive or the negative, will work to give us a solution. So the square root, if x squared equals 9, x equals either plus 3 or minus 3. So how does this help me with a quadratic? Well, going back to our perfect square trinomial pattern, if I factor this to x minus 5 squared, that's our special pattern, equals 7. Now I can take the square root of both sides. The square root of anything squared is itself. So the square root of x minus 5 squared is x minus 5. It equals plus or minus the square root of 7. I don't know what that is. It's some sort of a decimal. But in order to solve for x, I'm going to add 5 to both sides. So my final answers are either 5 plus the square root of 7 or 5 minus the square root of 7. And we'll look at this with our calculators a little bit once we get into class together. So take the square root of each side. If the left side is a perfect square trinomial, I can write it as a binomial squared, and then I can take the square root to solve it. Now, our previous method, let me just back up for a minute, would have been to subtract 7 from both sides to set this equal to 0, and then try to factor it. Well, if I did that, there are no factors of 18 that add up to 10. So this does not factor, and I cannot solve this with factoring. I could solve it with graphing by setting it equal to 0 and graph, but as you can see from my solutions, the values would not have been at whole numbers, but rather at a decimal that we couldn't figure out from looking at a graph. So finding the square root gives us a very accurate answer, 2 accurate answers that we can use. So to use the method from example 2, sorry, this got cut off a little bit. To use the method from example 2, the equation on one side must be a perfect square trinomial. That means that I have an x squared. The middle term is 2 times a times bx, and the last term is b squared. Now, the ones that we're going to use, a is always going to be 1. So this is the formula that we need to find in order to have a perfect square trinomial. If the equation is not a perfect square, we can create one by using a process called completing the square. So let's look at this. So x squared plus 12x minus 3 equals 0. This is not a perfect square trinomial. So I'm going to do one example, and then I'm going to give you all of the steps to write down. So the first thing I'm going to do is I'm going to take this negative 3 and add it to both sides, because I need a perfect square here. So I'm going to get the 3 out of the way, and what I'm going to do now is I'm going to add a new value. Since I add it to the left, I have to add it to the right, that will make this a perfect square. That number that I want to add is half of the middle number and then squared. So half of the middle number is 6. 6 squared is 36, and I'm going to add it to both sides. So now I have x squared plus 12x plus 36 equals 39. This is a perfect square now, x plus 6 squared. Remember my perfect square factoring. X times x is x squared. 6 times 6 is 36. And if I multiply these together and double it, that's why I took half of it, I will get 12 in the middle. Now I can take the square root of both sides. I get x plus 6 equals plus or minus the square root of 39, and subtract 6 from both sides. So those are my two solutions, negative 6 plus the square root of 39, and negative 6 minus the square root of 39. Okay, let's write down the steps. The first step is, if necessary, make the leading coefficient equal to 1. Remember back here, I said that we were always going to just have a 1 here. So if I have to, I'm going to make the leading coefficient equal to 1. I'll show you how to do that in a minute. Move C, the constant, to the right side and leave spaces to add a new number to each side. Choose the number to replace C by using half of B squared. Remember, that's how we found our 36. Add that to both sides. Now, factor the side with the perfect square trinomial using x minus half of B squared. Just write this down. We'll do another one in a minute. Take the square root of both sides and then solve for x. So make sure you jot all those down. Look at how these steps relate to the example we did just a minute ago, and then I'll do another example for you. Okay, so here's our example. In this case, my leading coefficient is already 1, so I don't have to worry about it. And in this case, actually, the constant has already been moved over. So all I have to do is leave a space to add a new number in. I want to create on the left-hand side a perfect square. So b is negative 8. I'm going to take half of that and square it. So I'm going to add 16 to both sides. On the left, I now have a perfect square trinomial that'll factor to x minus 4 squared. Now it equals 20. Take the square root of both sides. On the right side, I need my plus or minus. The square root of something squared is itself. And then add 4 to the other side so I know what x equals. In this case, I can also simplify the radical. So my final answers are 4 plus 2 root 5 and 4 minus 2 root 5. And we can just leave it written this way. All right? Well, let's try another one together. See if you could do the first step, which is to move the 3 to the other side and leave some spaces. So I'm going to put a new number in here that'll give me a perfect square, subtracting 3 from both sides, and remembering that whatever I add to the left, I have to add to the right. All right, take a second again, pause, and see if you can figure out what number goes in the blank. Okay, I take b divided by 2 and square it. That's 7 squared. which is 49. So I'm going to add 49 to both sides. The next step is to factor the left-hand side using the perfect square number, my 7. So x minus 7 squared. Notice that that middle is twice as much as the 7, and that's going to equal 36. Take the square root of both sides. X minus 7 equals plus or minus. This happens to be a perfect square, so I can get a whole number. Add my 7. So now my two solutions are x equals 7 plus 6, which would be 13, and x equals 7 minus 6, which would be 1. Now the little trick about this is that if we get a whole number solution, in this case 13 or 1, this was actually one that we could have factored. Let's solve the same one with factoring. X squared minus 4x plus 3 equals negative 10. Remember, to factor, I have to set it equal to 0. I'm looking for factors of 13 that add up to negative 14. That would be negative 13 and negative 1. And then setting each factor equal to 0, you see that I'm going to get the exact same solutions here that I got up here. So two different methods, both of them worked on this one. On the previous ones where we got a radical for our answer, those would not factor. So the only method that I could have used would be completing the square. All right, one more example. Complete the square can only be used if the quadratic has a leading coefficient of 1. If the leading coefficient is any other number, first divide all the coefficients by the leading coefficient. So, first of all, I'm going to put this in order. 5x squared, subtract the 20x, and that's my standard form. I'm going to divide everything by 5. X squared minus 4x minus 1 equals 0. I can tell by looking at this that it's not going to factor. There are no factors of negative 1 that add up to negative 4. So I'm going to start my complete the square process. I'm going to get rid of this number because it's no good to me. Put something different in its place, add it to both sides. Half of negative 4 squared is negative 2 squared, which is positive 4. Add 4 to both sides. The left side now will factor with my perfect square factors. Take the square root of both sides. X minus 2 equals plus or minus root 5. And x equals 2 plus or minus root 5. Okay, I know that there's a lot of steps to this and it's a little bit confusing, but we will work on it together in class.